Okay, let's take a look at this problem number 2. They're giving us a fitness test where we have the before and after scores. And we have to assume here that the 10 randomly selected participants, their scores here are shown before and after. So these two scores are the same people, they're before and they're after, 29 and 30, all 10 of the participants. So you can see, obviously, you want to find out if there was any kind of improvement after they completed this course. So since you have the same 10 folks, we're going to go ahead and say that these guys are independent. The scores depend on one another because they are the same people, right? So what we're going to do in theory here is if we take the difference or subtract the before and the after, so we take the after scores from the before scores, if we get a positive average all the way across, it's significant enough, then we're going to say that this course did in fact help them with their sit-ups. So, if we took the difference between 29 and 30, you would see here, first participant, so I'm having a little trouble with this, and this would be a net increase of +1. Second participant increased by 4. We got no increase at all, so it was lazy in that one. The next one will be an increase of 6, etc., right? And I don't see anybody who went negative. So what we're trying to do is, we're trying to see if there's an increase. So what we're going to do is, we're going to make a hypothesis statement, and we're going to say that null is that there was no increase. In other words, the mean of the difference will designate that UD is equal to 0. So if it was equal to 0, that means that overall the average was nobody increased and nobody decreased, right? And we can clearly see that it looks like we pretty much across the board have significant increases. So all our alternative statement is going to be that the mean of the differences UD is greater than 0. So we're going to utilize the calculator for this, and we're going to make a couple of assumptions. Not really that big of an assumption, but these data between the before and the after are dependent on each other because they are the same group of people. Alright, so let's go ahead and open up our calculator here. And of course, we've got to get this data into a list, so we're going to hit Stat, Edit, and we're going to go ahead and put in the list number 1, the before scores. Oops. Try that again. 29, 22, 25, 29, 26, 20, 36, 34, and 528 is the 10th participant. And then let's go into their after scores in list 2. And find the last participant. Alright, so this is a pretty small set of data. We could easily subtract these ourselves, but let me just show you how to use the calculator to do this for you. In list 3, I can tell the calculator to subtract L2 from L1 and give me the result. So this. So all you do is, just use your up arrow key to get into the title section here. And we're going to put this 2 minus this 1.
So if you look here, my blue keys, this number 2, if I hit second and L2, or second and 2, it'll give me L2 minus second and number 1, and you can see that it populates it with the difference in list 3. So if we refer to our statistics chart, we're going to make sure we pick the right test. So we have the difference of 2 means and their dependent samples. So using the hypothesis test, we're going to set it up as a stat test 2, which is a t-test. So here we go. Let's go back up here, get the calculator back on, and let me just quit out of this screen and go to stat test number 2, regular t-test, and here, you know what we didn't do? Let's go ahead and do this first. Well, we did do it. Our mu naught, our null statement, is that the population mean remained unchanged. That is, it's equal to 0. Our list is actually not in list 1, it's in list 3. So we're going to hit second and the number 3, change that. And since we're looking to see if we have an increase, we're going to be using a right tail test, which is greater than. So select that one, and then we're going to go down to calculate and see what we get. So we're looking for our probability is, you can see here, is 0.0020. 0.0020. Whoops. Our probability is equal to 0.0020. And that's a fairly small probability. So chances are, whatever our confidence interval is, that's going to satisfy it. So let's go back up to a 98% confidence interval. Remember, that's going to tell us that our alpha, our alpha is going to be 0.02, just 1 minus 0.98. Which should be 0.02, and we have 0.002 if you'll look at the calculator, and you can see that our probability is quite a bit smaller than 0.02. So it looks like we're going to reject the null. We're going to reject this null, and we're going to accept the alternative. I just now read this again, and it says find the 98% confidence interval estimate for the mean gain and the number of sit-ups. So what did we just find? We just actually did a hypothesis test, but let's go ahead and do the confidence interval, which shouldn't be a big deal because we already have the stats in there. So we're going to actually perform this test, a t-interval test, which is stat test number 8. And we're going to find that it gives us basically the same results. We have a stat test, we'll arrow down to number 8, and we're looking at our t-interval, and we're going to take it from our data, L3, and it's going to be a 0.98% confidence, and we're going to calculate it and record these values here. We have 1.83 is our low end, and our high end is 12.17. So let me just write that down. So our confidence interval is between 1.83 to 12.17. 12.17. And that's at a 98%. Make sure we change that to the right percentage here. Stat test number 8. Yes, we changed it to 0.98. And so, based on this information, if we ran this test repeatedly with 98% confidence, we would get an increase, a net increase of positive 1.83 to 12.17 sit-ups per minute. So that's, looks like just using that, it's a pretty significant increase in scores. So even at the low end, we're consistently going to be getting a net increase. So the data does show on average that students do have an increase, significant increase, using this test. Alright, I hope this video was helpful, and please let me know if you have any questions.